Hello everybody, welcome to this year's 2021's QLSC 612 Introduction to Programming in Python. I am your instructor and my name is Jacob Sanz-Robinson, and this lecture is designed to get you up and running quickly with programming in Python. It is expected that you have Python 3 installed according to the setup instructions on the website. I will be using version 3.7 and hopefully you will have version 3.7 or later installed so you can follow this through with no issues. And it's also expected that you have some basic previous experiencing in a scripting or in a programming language, because then this way, instead of, for example, explaining to you what a for loop is, I can just explain what the interesting thing about for loops are in Python, which I think is the gist of this module and the interesting part about it. So my job here will be to guide you through the fundamental syntax, concepts, and data structures required to get coding quickly in Python 3. Okay, so the main bullet points I have to speak about the introduction to Python are inside this Jupyter notebook, and I'm not sure that everyone here is familiar with what a Jupyter notebook is, but if you're not, it will be introduced in one of the next lectures. And I just felt it would be good to point out that all of the code I'm going to go through in today's lecture, as well as all the code I'll go through in the tutorial session, the live tutorial session, will be on the GitHub course material repository. So if you just go to the Introduction to Python folder in it, you will find all of this material nicely written down. So the first question that many of you are probably asking is, why on earth Python? Why are we putting ourselves through Python? And to put it in a short fashion, Python is quite a simple language in terms that it has an easy-to-learn syntax which emphasizes human readability, and many humans therefore find it efficient and intuitive to write in. It was created quite a while ago, 30 or more years ago, and since then it has amassed quite a large community following, which means you will find ample support online if you ever run into troubles. And particularly since 2012, it has experienced a huge amount of growth, and it has become one of the main programming languages that is used in academia and is used to fuel the machine learning movement, as well as being used quite a lot in industry, and it had funding from lots of different important sponsors in the industry. It is also a programming language that allows you to import libraries, meaning you can reuse chunks of code other people have written, which makes it immensely powerful to build impressive things quickly. In terms of conceptual basics then, Python is described as a high-level language, and this basically just means that it has a strong abstraction from the details of the computer or of the machine language, so you won't have to deal with writing in ones or zeros or allocating memory and dealing with registers, and it also has a lot of nice built-in data structures that will make your life a lot easier when you're trying to wrangle data. It's an interpreted language, and for those of you that have in the past coded in C or C++, you will remember that you had to compile this code, and this basically consists of a process where the computer translates your human understandable code to machine understandable code and then feeds it into the CPU so the CPU can execute it. Python code also undergoes a translation process, but it is translated into bytecode, which is also a low-level set of instructions, but these are executed by an interpreter on a virtual machine and not in your CPU. The interpreter checks the validity of all the different variable types and all the operations on every line of code, and this means that you don't have to declare variable types and things like that, and you don't need to have them checked on compilation. This has the advantage that, given that your bytecode and the virtual machine are of the same version, the bytecode is platform independent, and it can be executed on any platform, Windows, Mac, Android, Linux, anything you want to. And the cost of this is that typically it takes a little more time to run than compiled code. Another important point worth mentioning is that it is an object-oriented programming language. It is organized around objects, and everything we will see in Python, all of the data structures, lists, dictionaries, classes, etc., everything you see is an object in Python. We won't go deep into the object-oriented philosophy today, but if we have time at the end, I'll show you how to make a class quickly, for those people who are interested in using object-oriented programming in Python. But most of the stuff we'll do will be simpler scripting stuff. It is a programming language that has dynamic semantics, and this basically just means that variables are dynamic objects. So you can set a variable to an integer and then change that same variable to be a string and etc. So it allows you to assign variables in a way that makes more sense to a human than it necessarily does to a computer, and it deals with this behind the scenes. I'm not going to be running all of this code on a Jupyter notebook. I'm going to be showing you how to do it the more old school way, so to speak. And basically this consists of a text editor. This is just a regular text editor like Notepad or anything else. And a terminal window. So this is a terminal window. Okay, so let's run a really simple piece of code. Let's do the classic hello world. You will see that in my terminal, I navigated to the directory, which will be the same directory where my code is in. So I'm going to save this in desktop, because I'm in my desktop there, and I'm going to just save it as a .py file. I can comment things in Python. I hope everyone here knows what the comment is, but if not, everything after the comment is ignored by the interpreter, and the comments serve to make your code more human readable so that you can explain what's going on. And if I wanted to run this code, I would simply go and I would type Python or Python 3, depending on how you've set it up. For me, I'll type Python 3. Followed by the name of your Python file. And you will see here that it prints hello world. And this is because we have called the print function to do so. While I am sure you are probably already familiar with integers and the such, I will give a brief word on simple data types. And variables can store data of different types, and all these different types can do different things, and we can use different operators on different data types. Python has many built-in ones, and a few of them are more fundamental than others, and they can be combined to build more complex ones. But a few of the more fundamental ones are integers, which are just positive or negative whole numbers, such as 5. Then there's also floats, such as just 5.0. So floats, just real numbers, right? The decimal point divides the integer and the fractional part. There are also strings, like the argument we gave the hello world function, and that's just a sequence of characters. And there are also booleans, which represent one of two values, either true or false. And if you ever want to know the type of something, then you can just use the type function. And I'm going to run that code with the changes I made to it. And you will see that it is telling me that the type of 5.0 is a float, a floating point number. The next thing to move on to are variables and basic arithmetic and logic. So most of you probably know what a variable is, but if not, a variable is a container for storing data values. And you should just think of them as names that are attached to a particular object. So a variable is created when you assign a value to it. For example, if I wanted to create an age variable, and then I can also update the variable. And I can update it in quite a few different ways. And every time I do one of these things, and update the content of the variable, you can see that it is indeed updated. So I'm placing a print statement to print the value of the variable after each of these updates, so you can see what happens. You can see that it goes 12, 24, then I added a value of 2 onto that, then it goes to 26, added 4 onto it, and it goes to 30. Arithmetic, as you see, is something that can be done, and there are a few common operators. There are ones that you probably know of, right? There's plus, and there's minus, and there's multiplication, and there's division, 4 divided by 2 there, and there's also exponentiation. That would be a to the power of b in that last one. And then there's also modulus, which gives you the remainder of a division. So I think if I was going to show one, I'd probably show the modulus one. So if I want the remainder of 5 divided by 2, I would do that. And you will see that it gave me a remainder of 1, as is the right thing to do. One thing I do think is important to emphasize is that the order of operations matters, just as it does in real life or real math. So if you have 3 variables, like these 3, A, B, and C, all equaling different things, and then you have two different mathematical expressions, right? One of them is A plus C over B with no brackets around the A plus C, and another one has the brackets. And then we run that, you will see that it gives 2 different answers. So remember that order of operation matters. Logical operators are also a thing that is important, and say we have 3 variables that are booleans, which remember can take values true or false, so variables like this, then we can use operators from truth tables such as and, or, not, things like that. So if we do print x and y, it's only going to print true if both x and y are true. So in this case, 1 is true and 1 is false, and therefore it will print false. And if I use or, then it only requires one of the 2 of them to be true. So then if I run it again, it's going to be true. And if I just wanted to negate the value and switch the value inside the variable, I can just negate it with a not. So y is false, so not y should be true. I can also compare objects and compare their equality using this sort of operator. So now say I have 4 variables, x, y, z, and a. And x and y are 1, z is 547, and a is a string, which is hello. And then there are many ways I can compare these things. And here are a bunch of them. So this compares equality. So if x is equal to y, as should be the case in this, then it will return true. This will tell me what happens if not equal to is true. So if x is not equal to z, as should be in this case, then this will evaluate to true, because x is not equal to z. You can also use greater than, you can also use greater or equal than, less or equal than. There's a whole bunch of these that are possible. So you can see how each of these maps to each of these. The next data type I'd like to discuss is strings. So strings are a sequence of characters that are in between quotation marks, such as this. hello, I am a string. And a single character is just a string of length 1 in Python. There is no difference between character and a string. Python has something called string indexing, which allows you to access a particular character inside a string. And it also has something nifty called string slicing, which helps you to easily isolate a subset of a string. And there are also quite a few other inbuilt functions for them, so I'll go over these. So, say for some reason you really wanted this H. You really wanted that first character of the string, and you wanted to obtain it. You wanted to isolate it somehow and be able to do something with it. Well, the way you do this is through string indexing. And each of a string's characters in Python corresponds to an index number. And if you're going from left to right, you start with index 0. So this is index 0. And if you're going from right to left, you start with index -1. So say I want that H, and I want to print out that H into my terminal. So I'm going to access through the square brackets the index 0 of the message variable. Whoops. So you will see it printed the H there. And if I wanted the second one, then I would simply replace this index 0 with the next one, which is index 1 and corresponds to the E. And so on. If I wanted the L, I would use index 2, and if I wanted the other L, index 3. If I want to go the other way around, and I will say want to access the last index, then I would simply start not with 0, but with -1. And then if I wanted the N, I would just go to -2. And so on. I think you understand the pattern there. Similarly, there's a nifty thing called string slicing. And this basically consists of putting a colon inside your index. For example, this. And you can also have a second number after the colon. And the reason it's useful is it pretty much allows you to isolate a subset of this string. So if you provide 2 numbers, then the first number is where the slice starts, so inclusive. So if I put 0 here, it would include that H, which is the 0th character, and that would be the beginning of the substring I'm isolating. And however, the second index is where the slice ends, but it is exclusive, so we don't use it there, right? So let's just say, for example, I want the 8th character all the way to the last character. I don't know what the last character is, so it's fine. I just leave that blank. Here we are telling it that we want the 8th character because we start at index 0. So we want the 8th character all the way to the last character. And if we print that, you will see it is I am a string, because this is the 8th character and it goes all the way until the end. If I wanted the 8th to the 11th character, then what I would do is I would do this. You see, there's a second number after the colon. And this just gives I am. It just isolates that. And you can also use negative indexing to do this. Right, so if we start at -1 and then we go all the way back to -7, and it's exclusive, this last number, so remember that. So we're going from the 8th character to the 7th character from the right backwards. And you will see that this is I am a. Other than this nice indexing and slicing syntax, There are also many built-in functions that Python has, and I encourage you to read up on all of them outside. You can just Google Python string methods and you will see that there's many of them. And it's just inbuilt functions that you can call on a string. So for example, if you wanted to find out the length in characters of this string, I've just called the len function. And you will see that this string has a length of 20. And I can also create a new string by concatenating various strings. And I can just do so using the plus operator. So if I wanted to add something onto this message, I would use the plus operator. And you will see that here it is the two strings appended to each other. And you can also do this inside a variable or anything really. We can also see if a string is contained inside another string. So if we wanted to check whether the word string is contained inside the variable message, I would simply do string in message, right? So I'm checking whether the string called string is inside the message variable. And if I do that, you will see it returns the Boolean value of true, showing that string is in fact contained inside the message variable. And there are other things. For example, if you wanted to count the number of times I appears in the string, you would do something like that. Gave me an error. So let's see why that happens. Oh, because this needs to be a string. And you will see that there it tells me there is only one little I inside this string. And in fact, there is only one little I there. And there are many other methods available, really. I don't have time to go through all of them in detail, but I highly encourage you to read up on them. And there's a whole bunch of functions and a whole bunch of functions that belong specifically to the string class for string objects. And I just encourage you to read up on them. Next data type I'd like to show you is called the list. And the list is one of my favorite data types in Python. It is quite similar to arrays in other programming languages, but it has a few Pythonic quirks which make it a lot easier to deal with. And it also has many methods and functions that apply to it, which make using it a lot simpler and more intuitive in my eyes. So a list stores multiple items in a single variable, and these items are separated by commas and sandwiched in between square brackets. The items inside the list don't need to be of the same type. They don't all need to be integers like they are here, for example. You could have a few integers and a string and then a float. And lists are ordered, so they always respect a certain order that they're in when you're iterating through them. And they're also mutable. Mutable means that they can be changed. You can change the contents of a list without having to entirely create a new list. The elements of a list can be modified, they can be replaced, you can add elements to it, delete elements from it, you can change the order. It's just, it holds a bunch of them in one place, and you have a lot of flexibility that you can do with that. And you'll see here that I've pasted a few functionalities which look very much like what we just saw in the strings, and that is because it is also a sequential data type like a string, so there's quite a few things that Python makes sure you can do for both of them. You can access elements in it through indexing, much like strings, and it works in the same way. This will access the first element of it, And you can also slice them. Say this would get the first 3 elements of the string, right? Because the second one is exclusive, as we mentioned. We can also run that length operation on it. We can check if a certain element is inside the list. We can also print the sum of all the items in a list if they're of the right type, right? If they're all integers or floats, and they can be added. So I'll just run that to show you. Yeah, and you can see pretty much here that's printing the first element and the first 3 elements. It's printing the length of it, that there are 4 characters in it. It's printing that 345 is in fact in the list. And it's also then printing the sum of all the items in the list, which is 390. One of the common functionalities of a list, one of the common methods that people use to it, is the append method. And the append method is pretty cool. What it does is it just adds an item onto the end of an existing list. So if we appended this string to the list, right, we're appending hello to it, and then we're going to print it. You will see that it is in fact the same list with the string hello plopped at the end of it. You can also even append a list to a list. So now you'll have a nested list where there is one list inside another one. So if you also did append and then you appended a list to it, in this case a list with 3 elements, and then we print it, you will see that the last item inside this list is another list. And then you might be thinking, okay, say I want to get this, the first item of the nested list. I want to access that. How on earth would I do that? And well, the way to do that is just to use 2 sets of indices. So if we do this, right, we print my list 5 and 0, then this 5 refers to this element of the outer list, all right, of the original list. And then if this is a list and you access the 0th element of it, you're accessing the first element of the inner list, so of the list we just appended to the list. And in this case you will see that it is 3, because 0, 1, 2, 3, 4, 5, so the 5th element of the outside list. And then we want to access the first element of this. And then we can access that by using a second set of indices to access that 0 in it. We can also, for example, change a value, because lists are mutable. So if before printing this, if I went here and I said that I wanted the first item, right, the first index, the first item of the list to be 22 as opposed to 1, then I could just update it in this way. And then when I print the list, I can see that it is in fact 22. And I can also delete items from it, right? So if I just wanted to delete that first item from the list, and I just wanted it to completely disappear, then I would just write del before that element of the list. Del my list, first element of my list. And you will see that this deletes it entirely. Now the 22 has gone away, and we are just left with a 2 there. You can similarly to strings, if you have 2 lists, for example, in this case, if you have 2 lists, right, list 1, list 2, and then list 3, which is just adding the 2 lists, you will find that this concatenates. And then you'll just have one nice big list, which is 1, 2, 3, 4, 5, 6. The next type of data type I'd like to speak about is called the tuple. And the tuple is in many ways similar to a list. However, unlike a list, it is unmutable. It is not mutable, it is unmutable. And this basically means that once they are created, they cannot be changed. They are also declared as a comma-separated list. However, this is sandwiched in between round brackets and not square brackets. And that's how they differ from a list. So here we have some nice fruits Inside the tuple, we've got apple, orange, banana, and guanawana. I highly recommend you don't try guanawana as they taste disgusting. But tuples are very useful for grouping data together. And slicing and indexing is done in the same way as lists and strings, so I think I'll omit that and showing it. But many of the operations and functions we saw on lists still work on the tuples, and pretty much any of them that don't actually try and update the tuple will work on it, right? So trying to find the length will work, trying to append something to it, not as much. And why not? I'll just show a quick indexing to show how that works. And yeah, you can see that if we print tuple index 3, 0, 1, 2, 3, we get the hideous guanawana fruit printed. And I'd also like you to notice how if you update the tuple, it will make it absolutely freak out and cause an error, right? So yeah, so say we want to update the hideous guanawana to a grape, which is a much better fruit, superior in most ways, and then you print it, right? So print fruit tuple, you'll see it gives us an error, and it says tuple object does not support item assignment. And this basically just goes to show that you cannot modify a tuple once it has been created, and that is one of the big differences from a list. I think now that you've seen that tuples and lists have some obvious similarities, it is a good time to speak about casting in Python, and it's one of those neat features of Python which comes into use surprisingly often. And basically it means that we can convert data types into other data types through this process called casting. So let's see this little chunk of code. We have a tuple, 1, 2, 3, and then we are simply putting the word list before it, right? We're calling list as a function, and then we're feeding this tuple as the argument to the function, and then we're going to see what happens. And we run it, and we will see that this 1, 2, 3 inside the tuple is now a list, right? And we can also do it for some other data types. So if we had a string, right, just 1, 2, 3, and we wanted to convert this into a number, maybe you got this as input through the keyboard, but you actually need to process it as a number, so you want to turn it into an integer. So you can also do that. And you'll see that the quotation marks around it disappear, then now we just have an integer as our result. And I think it's important to note that the loss of data can occur if we force an object to be a specific data type. So for example, if you were to cast a float into an integer, then some of the data, that decimal part, would be lost. So exercise caution when you're casting from one type to the other. It is something that is extremely useful, but just make sure that when you're doing it, it makes sense to turn one data type into another, and information is not somehow getting lost, or and you're not just somehow messing stuff up that way. But yeah, if you just put the type and use the type as a function, then oftentimes you can successfully convert very easily data types from one thing to another. A data type that comes up quite often when we're dealing with real data sets or need to store complex information that has a particular structure is a dictionary. And for those of you who are used to Java or many other programming languages, it's similar to something called a hash map in those languages, right? So dictionaries store entries as pairs. These pairs take the shape key, value. And here is an example of a dictionary. And once again, the guanawana makes an appearance. And this is what the dictionary looks like. And you'll see that there are many sets of key, values. And as of Python 3.7, which is what this tutorial is in, a dictionary is an ordered thing. And dictionaries are mutable, and they don't allow duplicate entries. Note that before 3.7, dictionaries were not ordered. A key value pair, for example this, consists of two related objects. The user can use the key, this thing, the first of the two values. The user can use the key to access the value, so to access this thing, for any member of the collection. Dictionaries are commonly used to store datasets and to retrieve values from datasets by specifying the corresponding key. So to define them, you also use a comma-separated list. So you have a comma-separated list of key value pairs. Here's one, here's another, and you enclose them in squiggly brackets, or as I think they're meant to be called, square curly braces. And we're going to see the basic functionality of these data structures. So if we have this dictionary, right? And then we want to find what, say this is the amount of fruits, right? Say we have 3 apples, 9 oranges, 12 bananas, and fortunately 0 guanabanas. And say we want to find out, this is a data set, and we want to find out how many apples there are. So what I would do is similar to the indexing function in strings and lists, but now instead of accessing an index, I'm going to access a key to then obtain a value. So I'm going to go to the fruits available dictionary, and then I'm just going to look up apples in it. And if I do that, you'll see that it prints 3. So we have 3 apples. And it's worth mentioning that these keys, they can be any immutable type. So they can be strings or integers or even tuples. The normal thing is that I think we use strings. We can store dictionaries inside of dictionaries, and these are called nested dictionaries. So much in the same way that we stored a list inside of a list. So say we have this nested dictionary, and you can see that we have an apples key, and then the value is another dictionary. And then this other dictionary has a seeds key, and then it has 8. So the 8 seeds inside of an apple. And if we wanted to access the number of seeds, we would also do a double sort of lookup, right? Similar to the double indexing for the nested lists, but now looking up 2 different keys. First, we want to access apples, and then once we've accessed the value for the apple key, then we want to search up the seed key and obtain the value for that. So if we run this code, you will see that it gives us a value of 8. Here's a slightly more realistic dictionary, and it is called Fruits Nutrition. And it only contains 2 fruits right now, an apple and an orange. But you can see that the first key value element is apple, and then another dictionary inside that apple that contains a bunch of things like calories, water percentage, the grams of fiber. And then the second key value element is orange, and this same nested dictionary for the value, right? And this is a very common sort of format that you will find in many data sets and in many JSON format data sets that come in this. So first of all, what would happen if you wanted to find the amount of calories that are in an apple? Well, what you would do is you would do this. You would have the fruit nutrition variable that stores your dictionary. First, you would access the apple key and then the calories key, right? First apple, this takes us to the value, that is the nested dictionary. And inside the nested dictionary, you find the calories key. So this should give us 54 calories. If we've done that right, and we test it, and indeed it gives us 54 calories. Now, say we discover that this wasn't entirely accurate, and that there are actually 52 calories in an apple and not 54. That's important. And yeah, so we want to update this value in a dictionary. How do we update the value in a dictionary? Very simple. We simply have the dictionary and we call it and we access the apple, the calories, and we set that equal to the new value, in this case 52. And then if we print the calories in an apple again, this print statement here, we get that there are now 52 calories in an apple. So there are many different inbuilt functions that can be applied to dictionaries. One of them, for example, is we might want to list the keys or in a dictionary, right? So if we wanted to list all the possible keys, we would call the dictionary name .keys. And keys is a function, so we have that there. And if we run that, we'll see that the keys inside this dictionary, in the outer dictionary, are apple and orange. Now, say we wanted to print all of the keys in the inner dictionary, so we wanted to print all the keys of all the characteristics for apples. Well, then what we'd do is we would access the apple inner dictionary, and then we would call the same keys function on it. And then we can see that we get the calories, the water percentage, the grams of fiber in it. And similarly, we can do that for values. So what if instead of wanting the keys, we wanted the values of the outer dictionary? Well, we just call the apple, the dictionary, then the apple key, and then the values function. And we find that these values are 54, 86, and 2.4. Which 54, 86, and 2.4. So that's looking good. There's another way we can obtain a value from a key, and this way is useful because we can actually test if an entry exists without causing an error. So that way is to do this. We can call the get function. So we have the dictionary .get and then our key. And then if we do that, we'll find that it gives us the inner dictionary with all of the information of an apple. But now let's say we had this data set and it was huge and it just had a gazillion fruits in it. And you didn't know if the papaya was inside it, right? And if you did the other way, you would get an error. If you just tried to access the value of the papaya key, and there was no papaya in the dictionary, then you'd have a problem. It would encounter an error. However, if you do the get function and you try and do it, it simply returns none as opposed to returning an error and crashing all your code. So that's important. Now, dictionaries are unordered. So to add an item, all we have to do is the following. We simply have our dictionary and then we access the key, which is non-existent. So there are no bananas in this dictionary, but we definitely want to add a banana to it with all of this nutritional information. So we want to do all of that, right? So instead of having to append it like a list or something like that, we can literally just create a new element inside of our dictionary by trying to access it and setting it equal to the new element. So now if we print the whole dictionary, we will find that there is a new item in it, which is the thing we just added, the banana. And we can see all of the nutritional information for the banana. Now, similarly to a list, we can also delete items from it. So if we want to delete the apple from the original list, right? We just want to have the orange in there. Then we do that. We just write delete and then the dictionary and the key indexed. And you will see that now what it prints is an apple lacking dictionary because we just deleted the apple. And if we printed the list of keys, you would see that it now only contains the key for the orange. Now, there are many, many other operations that are inbuilt for dictionaries and are really useful. So you're probably bored of me saying this by now, but I do encourage you thoroughly to look them up because you might find they save you a lot of time. The next important thing to speak about to improve your knowledge of Python coding are functions. Now, A function is a relationship or a mapping between a set of inputs and a set of outputs. So it can be seen from the outside as a black box. And you're right, you just have a black box. You might not necessarily know what is going in there, but if you've written it, you do know. But in some cases, you might not have written it. It might just be from a library or something. And you have this black box, and when you give it an input, it gives you an output. And it allows you to create the blocks of organized and reusable code. So a function typically is used to perform a single action, and then you can just call it whenever you need to do that action. So I've pasted an example of a function here. So you can make a new function by using the def keyword and followed by the name you want to give it, and then the parameters in brackets, right? So you have the def keyword, then you have the name of the function, whatever you want to give it, and then it takes in certain arguments. It takes in the inputs inside the brackets, separated by commas. Then you have a colon, and then importantly, you have an indentation block. And everything that is in this same level of indentation will be inside the function. So if I wanted a code inside the function, I'd just write my code there. And whatever you type return before, this is what the output of the function will be. So basically in this case, we have a function called summing two numbers, and it takes in x and y, two variables as input. And it returns, its output is x plus y, right? So we can print it to see what happens. And we're calling the function summing two numbers with the inputs 1 and 4. So 1 and 4 go in, and then 1 plus 4 comes out. And if I run this, we will see that it does, thankfully, give me 5, which is 1 plus 4. And I have another little example here. And this is a function that is called appending to a list. And similarly, it takes in two inputs, an input list, and then a new item to be appended to the list. And you'll see that everything that is inside the function is on the same level of indentation, one level of indentation inwards. And we have our input list variable that it takes as input, and it uses the append function from the list to append a new item to the list. And then it returns the input list. So if we printed appending to list with an input list 1, 2, 3 and a new item 4, and we did that, we will see that the output is now a list which is 1, 2, 3, 4. However, I think this is a good moment to give you a slight conceptual note, which in a way that Python sometimes differs from other languages. So basically, the conceptual note is that all parameters, meaning all arguments to a function in Python, are passed by reference as opposed to passed by value. And this just means that the function gets passed a reference as an argument. Instead of getting passed the actual thing, the actual object, it just gets passed a reference to the address of the object. And this means that if you change what a parameter refers to inside a function, such as we do here, the change also reflects back in the calling function or the environment that you call this function in. To show you more concretely and practically what passed by reference means and how it can actually affect your work, I've concocted a small example here. So we have a function, right? We use the def keyword to define the function. We've given it a name, change list, and we've given it an input argument, a parameter called myList. So we grab that input argument and we append 1, 2, 3, 4 as a list to it. And then we print whatever the contents of that list are. And then we return. And note that we are not actually returning everything. That's the key thing that I want you to pay attention to right now. We're not actually returning anything in this function. We're not returning the list we just changed. We've changed our list, and we've done absolutely nothing else pretty much, right? We've changed the list, we've printed it, but we're not actually telling the function to return this as an output, our changed list. However, you will notice that I've created outside the function, so the indentation level has gone back to what it has originally, and this indicates that we are outside the function now. So we have my list with 3 numbers in it, 10, 20, 30, and we call our function on it, change my list. And if this was passed by value, which it isn't, but if it was passed by value, we would not expect this list to change because we're not returning anything that we've changed, right? However, in this case, when we run the code, you will see that we get the same thing for the value inside the function and the value outside the function. And this just means that because we passed a reference to the object as opposed to the object itself, now when we've changed the list inside of the function, the list has just changed in and of itself. So that's something you should know about and definitely be careful with when you are coding in Python. You will recall that at the beginning of this lecture, I said that one of the features that makes Python so powerful is that you can import libraries and therefore reuse code that people in the community have written, and you can call the functions they have written with very little effort. So some libraries are included by default in Python and some have to be installed. Installing these libraries depends on your environment manager. Perhaps you have Miniconda, like was specified in the setup instructions for this course, or perhaps you have a pip environment manager, and then you can just do pip install and whatever the name of the library is in your terminal. There are a few different ways to go about this that depend on the specifics of your setup. But let's, for example, use one of the inbuilt libraries in Python. Let's try grabbing the inbuilt math library, right? So one way to do this, to bring the whole library into the global namespace of this current Python script, this current module that we're on, then I can just write import math. And this, the library is called math, and we're importing the math library and everything it contains, constants, functions, etc. So for example, say you wanted to use pi in your code and you didn't want to have to create a variable with 3.1415 and a whole bunch of other stuff after that, then you can simply call use the math.py variable as a constant. And you will see here that they've got it to a nice amount of decimal places just ready for you to use. Similarly, say you wanted to calculate the factorial of the number 5, you don't need to necessarily write the code to write a function that calculates a factorial. This already has it inbuilt, so you just write math dot and then the function factorial with the input 5, and it will calculate it 120. So now I'm not going to go too much into the details of namespaces because that might be a little too advanced and specific for this particular module of the course. But what you can do if you just say want to import a function into your namespace as opposed to the whole library, and then this has the advantage that you can simply call the function as if it was a function in your code without having to do the math dot in front of it. So for example, you can do from the math library import factorial, and then you can just call the factorial function without having to write math dot before it because you've just imported this particular function into the global namespace. And you will see that this also works nicely in 120. If you go to the Jupyter Notebook in the course material repository, you will see I have another nice little example there of how to, for example, display a YouTube video in your code, which can be good if you have a notebook where you want to, say, instruct people in a certain way. But I'm not going to do that right here. As I have said a few times previously in the lecture, it's worth Googling exactly what libraries exist because there's many of them, and clearly I only covered the math one here. I didn't even cover the full thing, just gave you a quick example of it. So do some Googling, make sure you know what libraries are available to you, and if you need to do something very specific, if you can just Google a library to do that before you actually code it yourself, it will save you a lot of time and it makes Python quite powerful. So the next thing I want to speak about are if statements. And I'm sure, hopefully, most of you, if you've done some form of coding in the past, know what an if statement is. And in Python, you can just write one by using the if keyword. The code within the if statement is only executed if the specified condition in the statement evaluates to true. And this allows the code to make decisions based on the conditions that you provide. So, for example, say we have a variable x, which is 7, and a variable y, which is 3. So, if statements have the if keyword to say that it is a statement, then there's the condition, and this has to evaluate to true, and this is followed by a colon. But if this evaluates to true, then everything inside the if statement is executed. If this evaluates to false, then it is not executed. And everything that is inside the if statement is once again denoted by having the indentation, one indentation inwards, right? So if x is bigger than y, print x is bigger than y. So x is 7 and y is 3. So this should print x is bigger than y. And that's good. There is also something you can do, which is you can follow an if statement with an else statement. And this provides an alternative plan of action if this condition evaluates to false, right? So say now we have if, we've changed this. So say y is bigger than x. If y is bigger than x evaluates to true, it's going to print this. Then we take the indentation back, and now we have an else statement for the alternative plan of action. So else, so meaning if y is not bigger than x, then print y is not bigger than x. And in this case, now we have y is not bigger than x. So it's tried to do y bigger than x. It's seen that y is in fact not bigger than x. So then it's done else. It's done the alternative plan of action that we specified. And you can use all of the logical operators that we saw a little earlier on, such as ands and ors, to build more complex conditionals. For example, if we can chain them together. If x is not equal to 7, or y is equal to 3, print bingo. And in this case, we only need one of the two things to be true. So it prints bingo, because y is in fact equal to 3. And right, so you can just chain tons of these. You can have lots of or statements or lots of and statements all chained together in that. There's also a few other interesting examples I'd like to go over. So yeah, say we have a number list, right? It's just a list with a bunch of integers in it. Now we can also check whether a number is in a list, right? So if the number 42 is in the list, then print that it is. You can use negations, also logical operators. If 70 is not in the number list, right? So if not 70 in number list, print 70 isn't in the list. And similarly, we can chain conditionals. So if 42 is in the number list and 77 is in the number list, then both of them are in the number list, and you can print that. And this gives us that output. The next thing I'm going to speak about, and one of the ways which I've found Python really makes life easier for the programmer, is the way that it handles loops. I'm sure everyone here knows, but a loop is a sequence of code that is repeated until a certain condition is met. There are two main types of loops, for loops and while loops. And all for loops can be written as while loops, all while loops can be written as for loops. They are equivalent. So in the end, just pick whichever one makes your life easier. And firstly, I'm going to get started with just a very simple loop, not doing any of the nice object iterations that make them so useful in Python, just to display the basic syntax. So we have this here, right? And what happens is that we're declaring a variable to have an integer 1, and we're saying as long as this variable is less than 6, right? And notice that everything inside the loop is on the same level of indentation to make sure that it is known that it is part of that same loop. So while this is true, while I is less than 6, we want to print I, and we want to increase I. So what's going to happen is it's going to start executing the code. It's going to go, okay, I is 1, it prints 1, and then it's going to go, this plus equals just is the same as doing I equals I plus 1. So it's the same as doing that. They're equivalent things. So, yeah, it's going to go 1, and then it's going to increment to 2, and then it's going to start over, and it's going to say, oh, I is actually still less than 6. 2 is less than 6. So it's going to then print 2, and then increase this to 3 and such. So you'll see that if we run it, 1, 2, 3, 4, 5, it does what we want to. And another thing we can do is that we can use the break command to exit the loop. So it just terminates the loop that contains it. And an example of that is here. So it's the same loop, I equals 1, while I is less than 6, print I. But now we have a condition in that says if, so we've got an if inside our while loop, and therefore you can see that we need 2 levels of indentation, because the if will bring 1 level of indentation, but it's inside the while loop that also requires a level of indentation. So if I equals 3 at any given point, we're just going to break, and that means you just exit the loop that contains this break statement. So if we run that, you will see that the loop only goes all the way till 3. And this way you can tell the loop to abort if something has gone wrong. And now I guess, I'll still do one more example of this. If you were going to loop over a list the old school way, as such as in another programming language, you'd probably use a while loop, right? And here we have our list of fruits, again, inside the list. And we are starting a counter, which will be for the index in the list. Since lists are indexed starting at 0, we will start with our counter being 0, and we're going to say while x, while our counter is less than the length of the list, so in this case 3, then just print my list, right? And it's going to print my list at that index, and then we're going to increase the index. So if we run that, you will see that it prints 1 by 1 the element of each of these lists. And those are how you use while loops in Python. The cool bit about loops in Python is how for loop, so how the other type of loop, makes it very easy to iterate over a sequence. And this can be a string, a list, a dictionary, a tuple, all of the data structures that we've pretty much spoken about. You don't have to do the whole messing with the index thing to iterate through them. For example, we have the same list, orange, apples, and bananas, and we want to iterate through all the other things. You saw how we did it with the while loop, but if we're using a for loop, we can simply say for, we don't even have to declare this variable x, we can simply say for x in my list, and this instantiates it, print x. And it's just going to go through every element in the list and print it. You don't need to do more. You see, same output, orange, apples, and bananas. And there's other cool things you can do. For example, say you wanted to print out a list of numbers and you didn't want to have the whole incrementing a variable thing going on. Then you can simply use the for in range argument. So for y in range of 9, print y. And what that's going to do is it's going to print all the numbers up to the argument you provide to the range, but minus 1. So from this case, it's going to print from 0 to 8, not from 0 to 9, right? So it's going to go, if you call range n, if there was just a variable n here, it would print from 0 to n minus 1. And to exemplify this then, you will see that it goes all the way from 0 to 8, because we've provided 9 as an argument. And you can also make this more interesting. For example, you could change this to that. And what this says is that we are going to print all the numbers. Why? From 3 to 12 in steps of 3. So we're going to go all the way from our starting range, which is inclusive, to the ending range, which is exclusive, in steps of 3. And this will look like this. 3, 6, 9, 12. Right? 3, and then, yeah, this is exactly what we wanted. We're going from 3 to 12 in steps of 3. And you can also, you don't just have to go through lists in a fancy way. You can do any sort of sequential data structure. For example, for a string, you can loop over every character in the string by just, for y and string print y, or in this case, instead of y, I've just called it character. It doesn't matter. But if you do that, you will see that it goes string, all in a nice separate sort of way. A cool example of looping through a data structure, and something I really wish I'd learned a lot earlier when I started using Python, is how you can iterate over a dictionary, for example. So you'll remember our fruit nutrition dictionary from beforehand, right? We have apples, we have oranges, we have bananas as our key, and then as the value for each of these keys, we have another dictionary, and this contains all of the nutritional information in this data set. So one thing you can do is you can just go for the key in the fruit nutrition dictionary, print the key. And this way you will have apple, orange, banana once again printed. And you can also loop over both things together, because sometimes you want to have access to both the key and the value. So in this case, what you can do is you can go for item in fruit nutrition.items, print the item. And this .items part here will allow us to see both the key and the value at the same time as we loop through the dictionary, right? So it's first printing apple, then it's printing orange and its value, then it's printing banana and its value. And you can also update or delete items as you iterate over them. So for example, and you don't need to necessarily treat them together to do this. So say example, you have 4 key comma value inside the items, and this allows you to unpack from the joined key value item. It allows you to unpack the key and the value separately. And then you can print them separately. So print key, comma, and then value, and the calories from the value dictionary. And if you do that, you will see that we get apple has 54 calories, orange has 60, banana has 89. But you can imagine how this is very useful, because you can iterate through the dictionary, separate the key and value. You could perhaps update the value in a certain way, or just read a certain value. It's a very useful thing. The last thing I'd like to mention about loops is that you can also have a loop within a loop, known as a nested loop. And I've got an example here. Right, so we've got a for loop, and then after that we have a while loop inside the for loop. And I notice I'm lacking my list here. So yeah, we have a list, orange, apples, bananas, and then we have 4 item in my list. So we're going through oranges, then apples, then bananas. And then what's happening is, as we're going through each of these, we then encounter another loop. And you can see that it's a nested loop because it has double indentation. So there's this loop, and it's inside this overall outer bigger loop. So what's going to happen is it encounters oranges, and then it goes, while this variable that we just declared x is less than or equal to 3, we're going to print oranges, right? We're going to print orange, and then we're going to increment x. X is still less than or equal to 3, so it's going to print orange again, and then it's going to go again to here, and it's going to go, oh, x is still less than or equal to, it's going to be equal to 3, and then it's going to print orange again. Then this inner loop is going to terminate, it's going to go back to here, and it's going to go, oh, okay, now apples is the next item in my list, and then it's going to go ahead and print apples 3 times, and then bananas 3 times, and you can have many loops nested inside each other. But to demonstrate that, I run it, and you see we get orange 3 times, apples 3 times, and bananas 3 times. So I think it's good to reiterate that you should note that this inner nested loop right here has to finish before the next iteration of the outer loop starts. And I also just wanted to iterate that inside of the loop, the indentation level for that loop is indented extra, right? So if you're in the outer loop, you just need 1 indentation level, but the inner loop is going to have another indentation level on top of that. And I also think it's worth mentioning, if you remember the break statements that take us out of a loop, that if a break statement is inside a nested loop, it only terminates the inner loop, right? So if I had a break statement, for example, here, if blah, 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 and then break, if I had something like that, then it would only terminate this while loop, and we would still continue doing the outer loop. Another extremely useful feature in Python is called the exception. So exceptions are great and very, very useful. Often when we write code, we're faced with handling errors in it. Maybe something upstream didn't work quite in the way we expected it to, and now it damaged something upstream. Maybe it's a process that we're not fully in control of, depending on an external server somewhere, and it fails occasionally, and there's nothing you can do about it, and somehow you need to handle this. You need to handle certain errors that can happen in the code. And Python is cool because it offers us a way to allow us to gracefully deal with this. For those of you that have used Java, for example, this is similar to a try and catch block. And yeah, what basically the way of doing this is that the code is inside of a try block, and all the code that is inside this try block is tested for errors, right? It's code that you can test for errors when you're executing it. So say we wanted to print Z, and an error occurred in the printing of Z, and we want to deal with it. So if the code is inside the try block, it is code that when it is running, the code is going to be wary that an exception might occur. It's going to be waiting for an exception to occur or an error to occur. And then what we can do is we can use the except keyword to create an exception. So if we ran into a problem with this printing function here, then we can do something about it, and we can print an exception. Instead of the whole thing crashing and bringing everything to a dramatic grinding halt, we can simply say, oh, an error happened, let's not freak out, let's handle it. So now an error happened, and we are simply going to print an error occurred. And yeah, just the code inside the except block is executed if there are errors. And the code above, and this code here, catches the most general form of an exception. Exceptions are usually more specific than just catching this you see this green thing here. You'll usually put the name of the exact exception you are expecting to catch. If you don't really know what error is happening, you will go for the most general version of this possible, and the most general one is this except exception. So in this case, we run this code, right? It says an exception occurred, and this is simply because we haven't defined the variable that we're going to print. The code doesn't know what Z is, so now we're telling it to print Z, and it's going, what on earth are you trying to tell me to do? And usually it would give me a name error going, this thing hasn't been defined. But now, instead of doing that, we've told it that it can do an exception, right? And what I mean by this, I guess, is if I just did print Z, right, the stuff that's inside the try block, and I ran that, look, it's giving me a name error. Name Z is not defined. So if I undo that, I've undone it too far. But if I undo that, and now that is inside a try block, and we're handling it by catching it as an exception, then it's simply going to say an exception occurred because this is what I'm telling it to do. And this need not be a print function. Maybe your exception, your way of handling it consists of calling a different function here. It just offers you a graceful way to back out of it in case of something happened. If I was going to do that same code in a slightly less general way, in a way which would be nicer, say, a way that is more correct, then I would have the code that's going to go wrong, or that I think go wrong, inside my try block. I know that I'm expecting a name error, so I would say except name error, and then I'm going to print my name error. And then I'd have a general exception, right? The most general exception case, unless something I didn't predict went wrong. So if maybe for some reason I'm not expecting a name error, then I would have another one, which is just a general exception after it. And yeah, you will see here that it is still giving us the name error because it is the name error that went wrong. When we are defining exceptions, we're going to want to go from the most specific exception to the least specific one. So we're going to start by trying to find a very specific thing that went wrong in the code. And if we didn't succeed in finding the specific thing, then we move on to a more general solution, like decreasing the granularity of our sieve. And I guess the final thing I want to speak about when it comes to exceptions is the finally block. And the finally block is just something that always gets printed when you're done dealing with the exception, right? So same thing, we're printing Z, we're finding a name error in Z, and then regardless of what happened here, we want to finally do this. It's just going to tell us the try except is finished. When the try except thing has finished, it will always print this try except is finished, or it will always do whatever you tell it to do here. Right? So the finally block is always going to get executed at the end. Okay, we're almost at the end of this lecture. The last thing I'm going to show you very quickly, it's really all of a rabbit hole in and of itself, so I'm not going to go into much detail, and I don't think this is going to be assessed. But it is objects and classes. I mentioned earlier on that Python is an object-oriented programming language, and it uses objects and classes to structure code and how things behave in the code. So classes are used so that the user can create data structures, right? A class allows you to create a user-defined data structure. And here is an example of a class. I have the dog class, right? And I'm giving it a class attribute, such as the species. And I also can initiate it to have certain values within it, such as the name of the dog, the age of the dog, etc. And these constructors are within the class. You will notice that everything inside the class has a level of indentation too. You will also notice that other than the constructors for whatever object is created, we can also have methods which are just functions that are specific to the class. So in this case, it's just something that returns a string describing the dog, the name of the dog, and the self. And these classes, such as the dog class, are used to create objects. Yeah, so the classes define functions called methods, and these identify what an object created from this class can perform with the data which is available to the class. An instance is an object that is built from the class. So you can think of the class as a blueprint for an object and a blueprint for an instance, right? The object is the instance of the class. And the object actually contains the real data. It's not the blueprint. So in this case, we have a variable, my dog, and we are creating an instance of an object based on the dog class, this dog blueprint. And we are creating the dog with a name and an age. When we create this dog initially, we allude to this constructor paragraph here, which has the def init keyword for initiation. And we're going to create it with the name of Bonzo and the age of 7. And then you'll see that what happens when we try to print my dog.name, we're accessing the name attribute of this specific dog. And you'll see that the name is Bonzo. And then if we try and call the description function belonging to the myDog instance of a dog class, then we will have that our dog is 7 years old. It is executing this function here. And the stuff that we haven't initiated specifically, such as the species, will just be something that we don't have to provide in our constructor. And it is just something that will be available to every single dog we create, regardless of its name or age we provide. So regardless of what Bonzo, and that Bonzo is 7 years old, every dog is going to have this Canis familiaris. And I'm going to stop about objects here because it is indeed a rabbit hole in and of itself, as I said. And there is a lot of thought and methodology that goes into object-oriented programming, but it is perhaps slightly beyond the depth that this module should go into as an introduction to Python. So I think this is more for the more advanced users of object-oriented programming languages, so that they just know how to create classes and objects. And yeah, I think that brings us to the end of this lecture. Hopefully you will be more familiar with the syntax and the concepts and the ways of doing stuff in Python. And hopefully it has been clear, informative, and you have managed to enjoy it slightly. I highly recommend that you check out all of the material on the GitHub course repository, because if you didn't understand anything I said, you will see that pretty much everything I said is included in the Jupyter Notebook, and all of the code is inside this Jupyter Notebook. So if you missed anything, or if you find it just easier to go through everything by yourself and running all the code inside the Jupyter Notebook and seeing everything written down, including all the comments of what's going on, I think you will benefit a lot from looking at this notebook instead of hearing me drawl on about it. And I also thoroughly recommend that you join us for the live session, the live tutorial session, as I'm going to go through quite a few examples that will be quite similar to what you're going to find on the assessment for this course. And it should boost your understanding, introduce a couple of minor things that are useful and weren't introduced in this main lecture, and also go a bit more into the nitty-gritty of real examples, as opposed to just little toy examples for the sake of illustrating educational concepts. So, thank you for listening to this whole thing.